Hello, everyone, and thank you very much for joining us today. I hope you're all safe from wherever you may be joining us from. My name is Jonah DeLongchamp, and I'll be your host for our live quality training Aukom Level 1 presentation, which we are very excited to talk to you about, and where we're actually going to give you an example of how a section of Aukom Level 1 course would be held. Before we get into our seminar today, I want to mention to everyone to please ask us questions through the GoToWebinar tool, which is the question mark icon in a bubble, which is on the toolbar on your right-hand side. It should be under the hand icon to raise your hand, which you can also feel free to use, and we'll address your questions at the end of our presentation. Now, I'd like to give you a brief introduction to who we are at Wenzel. Wenzel is the largest family-owned metrology company, founded in 1968 by Werner Wenzel, and now led by his daughter, Heike Wenzel. We have approximately 650 employees worldwide, about half of which are in Germany, but with 17 subsidiaries worldwide and more than 50 sales and service partners as well. Our family looks after more than 10,000 Wenzel machines as well as third-party machines. This includes not just CMMs, but high optical speed scanning and computer tomography inspection equipment.
Yeah, that's some small technical difficulties.
Okay, here in this slide is probably the best shot of where our products are made. You can see in the different shapes, ceilings, which is a signature of how far we come. As a family company, we pride ourselves on giving a personal touch to every customer. We make your challenges our challenges, so that your success is our success. We have recently celebrated our 50th anniversary, and we are looking forward to the next 50 years. As I said before, my name is Jonah DeLongchamp, and I joined the Wenzel America team as an application engineer in August of 2009 until January of this year, where I've took over my new role as product specialist for portable metrology for the NAFTA region. And today here I'm joined with by my colleague, Mariano Marks, and now I'll turn it over to Mariano to begin.
Hello, everyone. As Jonah said, my name is Mariano Marks, and I am the application manager at Wenzel America. I oversee trainings, demos, SMAs, many different hats I wear, and I have been part of the Wenzel team since September of 2016. So I actually just hit my 4-year anniversary, and I'm looking forward to many more. So today I'd like to talk to you about what Aukom is all about, particularly to deliver a small training on a section of the Level 1 course. But before I do that, I wanted to let you know about how Aukom helps your quality department. So Aukom is a suite of courses designed for metrologists, production engineers, and even managers, and really anybody in the field of metrology to enhance their skill set through these 1-week training courses. This is going to help you do 3 things. It's going to help you reduce costs, it's going to help you minimize waste, and it's going to help you make effective decisions.
So Mariano, what does Aukom stand for? Is it an acronym?
Yeah, so Aukom actually stands for Ausbildung Koordinatenmesstechnik. I'm probably botching the pronunciation, but essentially it's coordinate measurement training, which is what we're all about.
And is this a European start in Europe or America?
Yeah, so this program was actually started 2 decades ago by a group of metrology companies in Germany in collaboration with universities and industry experts, with the aim of providing the same foundational knowledge to those who take the courses. This is almost a pet peeve of mine, for example, when providing support on our hotline, where I see terminology that, even though I know what is trying to be said, is misused, but maybe it's just not the regular operator working that day. Nevertheless, having the same concept and even language be used throughout the manufacturing process is invaluable. I don't have to say so for those of you who are operating internationally, for example. So this is why these courses are exactly the same no matter what continent they're in. I'd like to be the first one to deliver the training in Antarctica, though, if I could. I don't think we've established an Aukom flag there yet. And I'm actually from Argentina, so it wouldn't be a far trip from there. But anyways, when I first started here at Wenzel, my first metrology affair was with gears, spur, bevel, racks, worms, you name it. And a well-known concern in the gear industry is the gap of expertise and information that is anticipated due to a generation that will be leaving it and the lack of people that are entering it, either from no interest or absence of the tools to facilitate the transfer of this knowledge. If I want to search something on the internet, I go to Google. If I want a coffee, I probably go to Starbucks. If I wanted the best all granite CMM frame, well, who else but Wenzel? If I wanted to learn something, I can't say I didn't love all the math and physics courses I took in college, go Eagles. But if I was looking for metrology knowledge, you can now get it directly from the experts.
Oh, great. Can you give us an outline of the course structure for Aukom, please?
Definitely. So what you're looking here on the screen are the Aukom level 1 through 3 courses, which have 4 days of materials each, as well as the Aukom GD&T course, which is 3 days of material. The great thing though is that there is a test at the end of the Aukom level 1 through 3 courses. So in the 5th day in the morning, students take a test, which means that the course is certifiable and you're getting the latest knowledge in the field of metrology because the content is continuously kept up to date. I've also heard companies which have, for example, operators who, if all they do is place the part on the CMM and run a program, then they might need to be certified to Aukom level 1 in order to be able to do so. And if they need to maybe program on the CMM, then they must be certified to at least Aukom level 2. So this makes the results that are provided by the quality department more reliable and credible. So this is a slide that we show in every Aukom, which demonstrates exactly what I just mentioned, which is that the results we obtain from our inspection equipment must reflect what our part is actually like. Because if we say that the measurement is okay and the part is actually okay, then everything's okay. We can continue with our process. However, if our measurement says the part's okay, but the part is not actually okay and in tolerance, then this can be dangerous and there's going to be failures in the field, for example, where possibly people could get hurt. We've all heard of these recalls that have happening all over the world, in the automotive and maybe airline industries as well. On the inverse side, if we say that the part is okay, but the measurement's not okay, then this can be costly. This is going to end up chasing our tails in the production process, which is unnecessary and because the part's actually already okay. What we actually want is, if the part is not okay, then the measurement to also say that it's not okay, so that we're reflecting the right information back to production. So here are the topics that you'd find in the level 1 course. So we're starting off with the basics. We're talking software, tolerancing. We even work with some hand tools like gauges and calipers in the class. We look at software on CMM or any other inspection equipment that you have there at the facility, here or on site. So whether it's the first time you're seeing a CMM or you've been in the field for decades and would like to brush up on topics, this is a great place to start so that when you come across this, you'll know exactly what to do.
So Mariano, you mentioned that there's an exam at the end of the course. Do you do anything to help your students prepare for this exam?
Definitely, yeah. So we have end of unit questions at the end of each unit. We also have a practice exam that I hand out to the students in class and for them to take overnight to study. And we also review before the exam itself as well, so that we can make sure you're successful come test day. Okay, so the topics I'd like to train you on today is from a section of Unit 12, which has to do with measurement analysis, specifically the association methods that you might run across to determine the associated geometry. So essentially, your metrology equipment will usually get you a lot of data, which are the black dots here that you see on the screen. And so in the software, you're going to say, for example, for your line and circle shown here, and we're actually going to just mainly work with the circle because it's the easiest one to work with. But let's say you're asking the software for the diameter of a circle. The software is going to go, okay, I'm going to give you the diameter of a perfect circle. So you go, okay, thanks, software. So the software is going to go, hey, I have all this data, and I can give you the diameter of which perfect circle, because there's many that it can report. And so these here are the list of the 4 most common association methods that you run across in metrology software. We have the Gaussian or least squared circle that you probably already heard about, the minimum circumscribed and maximum inscribed elements that we can fit to our data, as well as the minimum zone, or also called Chebyshev association method. So this first association method is, again, the Gaussian circle. So what we have here is the data from your CMM, which are the red dots that you see on the right-hand side. And what the software is going to do with the Gaussian fit is take all of the points and do an equal weighing. So it's a mean. We're going to fit a perfect circle, which is the blue circle you see, and it's going to fit it kind of somewhere, quote unquote, in the middle. So you see that some of the red points are inside and some of the red points are outside. So this association method is commonly used for the production process. You're churning out parts, you're measuring things quickly, you just want the average of your analysis.
So, Mariano, when you say association method in Aukom terms, is this referred to what we call in Quartus as the evaluation method, or I've heard also this called in other softwares as fitting algorithms? Is this correct?
You're exactly right, Jonah. So association method, compensation method, evaluation method, these are all interchangeable terms that you'll run across different softwares. And this is a great example of how students enrich the class by bringing in their knowledge from different backgrounds and maybe softwares that they've come across.
So that could be very important. So what you're saying is that even with the same data, the data point sets, you would still need to go a little step further and make sure that you're applying the right association method or fitting algorithm or analysis, correct?
Right, yes. And so softwares like ours, Quartus, try to help you out by, for example, when you're measuring an element and you want to report the diameter, when you get that diameter feature, the software will already help you out by doing the correct association method for that circle, so maybe least squared. But when you're doing roundness, then it'll apply maybe a different association method, or for true position, and so on and so forth.
Like the Chebyshev would be for roundness or form. Right?
Exactly.
Okay.
So the next association method, to close up the least squared Gaussian association method, here we see that the assigned element is calculated using all of the measured points. So with all of the data that you get from your measurement equipment, it's going to average out using all of the data. We'll see why this is important in the next slide. So calculation is an averaging method. So since we're using all the data, outliers have very little impact on this calculation. So if you had outliers, a piece of dirt that throws one piece of data out, then the calculation is still relatively stable, right? If you had a bunch of kindergartners in the room and you had somebody who was 90 years old, the average age of the room is still relatively low. So, and then it says a statement about the form deviation can only be made when a large number of equally spaced points are used. Right, so we don't want to really make a statement about the form or shape of your part if you've got maybe 10 points for holes that are around less than 50 millimeters maybe. So the size of the part even comes into play as well. So we want to be able to do our due diligence and make sure that we do have enough data when applying these association methods.
And you can get more data from different sensors on your inspection equipment. As a CMM, as an example, you could put on a tactile probe or a tactile scanner if you want more data. Scanning would obviously get you more data. Tactile probes, you just drive up how many points you desire on that object.
Exactly. You're doing helical scans with a Revo. You're gathering hundreds, even thousands of points a second.
6,000 points a second.
That's right.
Up to.
Those fancy moves. Okay. And so the next association method we have here is the minimum circumscribed circle. So for this association element, we have the same data, those same red points that you see here from our inspection equipment. What we're going to do is we're going to take, again, that perfect blue circle, and we're going to start shrinking all that data. And we're going to make that blue circle as small as possible until I hit the outside 3 points. So the other thing that you actually notice about these Aukom courses is that it's manufacturer neutral. So this is the term that I like to use. So much so that actually in Aukom level 1, we've taken out the images of the CMMs of the logos and things like that and made them all just kind of like clip art and basic images, because again, the goal is to get that foundation of knowledge. We're just talking about the concepts in Aukom. So you'd be getting the same exact content, not only anywhere you get trained in the world, but no matter who trains you, since we are seeking to accomplish that same foundation of knowledge that's established throughout the industry. So if you have the same part that is being measured in, say, Italy and Canada, you'd get the same correct results in the end of your measurement report. So the next association method, conversely, is the maximum inscribed circle. So here, again, same red dots of data, taking that perfect blue circle and placing it inside all the data, and blowing it up as much as possible until we hit the innermost 3 points. So this association method, you'll notice for actually all of these circles, they're going to have not only different diameters, but different center points as well. You're getting different circles.
So Marian, it looks like this association method might be used for possibly a functional type check, a slip fit, possibly, looks like.
Exactly, you got it. So for checking assemblability, so if you've got that pin and the bore and you want to make sure they fit, you want to have the appropriate association method. So the pin will get the minimum circumscribed and the bore maximally inscribed element. So for these two association methods, as it says, this assigned element is calculated using the extreme points. So here, unlike the Gaussian, the outside points matter, those outliers, which we do want to make sure our part is always clean and set up correctly. We're going to be doing it with those extreme points when calculating these two circles as the image shows. So this assigned element is calculated using only a few points, the outermost or the innermost ones. And so on the bottom right, you can see how you also get a visual about how it would work with a cylinder element. So last but not least, we have the minimum zone circle, which is kind of a hybrid, if you want to think about it that way, between the Gaussian and the max inscribed, min inscribed. So what we have here is the same red dots of data. And the way to calculate this minimum zone circle is by taking two concentric circles. They have the same center point. One's placed inside the data the other one outside. We're going to blow up the inside one as much as possible, the outside one shrink as much as possible, until they're as close together as possible. Then we're going to take directly halfway in between circle, which is the blue one you see there. So here we end up again kind of like a Gauss circle, but it's just calculated differently. This association method, as Jonah mentioned earlier, is used when checking form. So the Chebyshev association method or minimum zone association method is again also calculated using those extreme points. So your outliers are going to matter. So you want to make sure your part is clean and set up. Okay. So it is calculated using those few points. So during class, one of my favorite things is when the students interact with each other. So whether I'm teaching on site at one company or in the office with a mixed class. So this might be a point in the class where a student realizes their production process a little bit more and matches it up with the type of sensor they have. So if it is a scanning sensor, like we talked about, Jonah, they'll ask another student that has also a scanning sensor how they go about their inspection. We might talk about speed, the type of styli they use, because they're all from different backgrounds. They have different machines, sensors, and they measure different parts with different materials, and they end up learning from each other.
That makes great sense. You know, I've trained a lot of different softwares over the years, and this would be a great thing for my students to have this Aukom level 1 and the explanation about these different association methods prior to coming to class, because it saves a lot of time for me discussing these in a basic class.
Definitely, and I'm glad you said that. I like to actually refer to this suite of courses as a step ladder that merges perfectly with our software offerings or other training providers. So that maybe you take your Aukom level 1 to get your feet wet at the beginning, then you come take Wordis basic with Jonah or I or another one of our AEs, and then maybe you want to learn further your knowledge. Your training department wants to invest in you. So you come take Aukom level 2, talk about more GD&T, maybe an optical sensor or what CT is all about. And then from there, you can go on to the specific GD&T course or come to us for customized training or what have you. So this is really the greatest thing about Aukom, that we can come together to have the same understanding about our own process, which in the end makes us all successful.
And there is a separate course at the end for specific GD&T, only dedicated to GD&T, correct?
Correct. And there we go over the difference between ISO and ASME, since ASME is mainly what is taught here in the US. And we go through each specific case to make sure you're applying it correctly in your software. And again, you're getting those correct results.
And it's universal.
It's anybody can benefit
throughout
from
the
it.
whole world.
That's exactly right.
All right, well, thank you, Mariano, for that look into Aukom level 1. And for all of you attending our live quality training, Aukom level 1.
And I actually also want to let everybody know to check out Philip's position, where I had the chance to do my first podcast with them to talk about not only Aukom, but how it relates to the education field. So how it kind of marries into educational institutions around our country.
And please make sure to submit any questions if you still have them. In the meantime, let us now take some of the questions submitted by the audience. So I see we have a question coming in here. Due to the recent pandemic, are you able to teach Aukom level 1 remotely?
Yes, definitely. So Wenzel being very flexible here, we've been able to adapt our trainings to over GoToMeeting. So for the Aukom level 1 and Aukom GD&T courses, we're able to hold that over the web, lecture-based, me with my PowerPoint, and I still mail that manual out to you, and we're holding the class just as if I were there.
Great. And I have another question coming in here. Can someone take level 2 and skip level 1, Aukom, if they think they have enough experience through level 1?
So if they want to do that, what they would have to do is you have to have the certificate from the previous level. And you are able to take the exam from level 1 alone, but of course, we recommend that you come to the course so you get familiarized with the specific terms of the course and then get that interaction with the students. So for level 2, you have to have the test passed from level 1. And for the level 3 course, you have to have the certificate passed level 2 and also have participated in the Aukom GD&T course, which currently has no exam for it.
So the GD&T course is prior to Aukom level 3?
That's correct,
Okay.
yes.
Oh, that's good.
Yeah.
That's good. So I have a question for you, Mariano, then.
Yeah,
So
sure.
there's no other questions coming in through the audience so far. What is your favorite memory of training Aukom, if you don't mind elaborating?
Ooh, nice. So I would say recently we had a group of students go through the whole curriculum, level 1 all the way through level 3, and that was really neat to see because spent a bunch of time with them, and they came to every class was different, right? Because they were different students, and it was awesome to see how their company invested in them. They were able to come here and go through the courses. Then when they go back and use Cordis, I'm on a texting basis with them, which is really great. So we just ask questions back and forth, and they're applying the stuff that they learned in the class. So that's the success story for me right there.
As a group,
Yeah.
through a universal certification program, if you will, this Aukom.
And it's being seen more and more around the world. There's more certificates and just the standard that the metrology industry is able to just bring to everyone. So.
Great. Well, I want to thank you everyone for participating. And if you have any further questions, please visit our website, or you can contact Mariano or myself directly, or via the sales@winselamerica.com for any questions you might have.
Thank you all.
Thank you.